Everyone. Today we will going to see some practice questions from the chapter Redox reaction, and this is part 2. Let's start. Disclaimer which says the images used in our slide deck are for educational purposes only. We respect the intellectual property rights of original creators and owners of these images. If you are the owner of any of the images used in this deck and have any concerns or issues, please contact us at sathi@iitk.ac.in and we shall remove the images. This is index slide. So we are going to see some practice questions from question number 8 to question number 15. Let's start with the question number 8. In which of the following pairs there is greatest difference in oxidation number of underlined elements? So we have to tell that in which of the options there is a greater difference in the oxidation numbers between the underlined elements. The options are NO2 and N2O4, P2O5 and P4O10, N2O and NO, or SO2 and SO3. You have 10 seconds to solve this question. After that, we will see the answer. Okay, let's see. So the correct answer is option D, that is SO2 and SO3. So in the option A, we have given NO2 and N2O4 and underlined the element is nitrogen. So in NO2, nitrogen is in +4 oxidation state, and in N2O4, the nitrogen is in +4 oxidation state. Therefore, the difference, as we have to tell the greatest difference in the oxidation number, and you can see clearly that there is no difference. So the difference is 0. Now in the option B, we have given P2O5 and P4O10. In the P2O5, underlined element is phosphorus, and in the P2O5, P oxidation state is +5, and in the P4O10, the oxidation state of P is +5. So as you can see, both of the oxidation states in P2O5 and P4O10 is equal, and that's why the difference will be 0. In option C, there is N2O and NO. In N2O, underlying element is nitrogen having +1 oxidation state. In NO, underlying element is nitrogen having +2 oxidation state. Here we can calculate the difference as both the oxidation states is different. So the difference will be 2 minus 1, which is equals to +1. The difference is +1. In the D and the last option, we have SO2 and SO3. In the SO2, element underlined is sulfur having +4 oxidation state, and in the SO3, the underlying element is sulfur having oxidation state +6. Here also you can see that oxidation states are different. So the difference of oxidation state is equals to 6 minus 4, which is equals to +2. So from the given options, we have in the D option SO2 and SO3 having the largest or greatest difference in the oxidation number. Right? That is +2. And thus the D option is the correct answer. Okay. Let's move to the next question. Question number 9. The oxidation number of an element in a compound is evaluated on the basis of certain rules. Right? We know that if we want to find out the oxidation number of a certain element, we have to follow certain rules. Which of the following rules is not correct in this respect? So we have given some rules here in the options. We have to find out the incorrect rule. Options are: the oxidation number of hydrogen is always +1. The algebraic sum of all the oxidation numbers in a compound is 0. An element in the free or uncombined state bears oxidation number 0. In all its compounds, the oxidation number of fluorine is -1. So you have 10 seconds to solve this question. After that, we will see the answer. Okay, let's see. So the correct answer is option A, that is the oxidation number of hydrogen is always +1. So as let's see, so you can see that in the B option, the algebraic sum of all oxidation number in a compound is 0, which is a correct rule, right? In the C option, an element in free or uncombined state bears oxidation number 0. This is also the correct statement. In all its compounds, the oxidation number of fluorine is -1 because fluorine is a halogen. So this is also a correct rule of oxidation number. But in the option A, the oxidation number of hydrogen always +1 is not the entirely correct statement, because the oxidation number of hydrogen is +1 except in the ionic hydrides where it is -1, and in H2 where it is an elementary form, so the oxidation state will be 0. So we can't say that the oxidation number of hydrogen is always +1, right? And thus the not correct statement which we have to find out is in option A, and thus option A is the correct answer. Okay, let's move to our next question. Question number 10. The oxidation number of sulfur in S8, S2F2 and H2S respectively are. Nothing, just we have to find out the oxidation of sulfur in these three compounds. Options are 0, +1 and -2, +2, +1 and -2, 0, +1 and +2, or -2, +1 and -2. You have 10 seconds to solve this question. After that, we will see the answer. So let's see, the correct answer is option A, that is 0, +1 and -2. So in the S8, as sulfur is an elementary state, right? Not any other type of atom is attached to the sulfur in this molecule. So the oxidation state will be 0 for the sulfur. In the S2F2, the fluorine is in -1 as always. So the if we find out the S2 oxidation state in this, so sulfur oxidation state will be coming out as +1. And in H2S, as H2 is having +1 oxidation state, so S is having -2 oxidation state when we find out. So therefore, oxidation number of sulfur in S8, S2F2 and H2S respectively are 0, +1 and -2. Okay, and how can we determine this? Because we just have to keep in mind the rules of determining of oxidation number of an element in a compound, and then we can clearly find out the sulfur oxidation number in these three of the molecules. Thus the correct answer or the option is option A. Okay, let's move to the next question, question number 11. In which of the following the oxidation number of oxygen has been arranged in increasing order? So we have given some molecules, some compounds in the options, and we have to arrange the molecules on the basis of the oxidation number of increasing oxidation number of oxygen. Options are the most in OF2, then O3, then KO2, then BaO2. Most in O3, then BaO2, then KO2, then OF2. Most in KO2, then OF2, then O3, then BaO2. Or most in BaO2, then O3, then OF2, then KO2. So you have 10 seconds to solve this question. After that, we will see the answer. Okay, let's see. The correct answer is option A, that is the OF2 is having the most highest oxidation number of oxygen, then O3, then KO2, and then BaO2. So if we find out the oxidation number in the OF2, it will be +2 because F will be -1, so O will be +2. O3, as this is an elementary form of oxygen, so it will be the oxidation number will be 0. In KO2, oxygen has -0.5, or you can say -1/2 fractional oxidation number. and then in BaO2 the oxygen will be having -1 oxidation number. So we have arranged this in the increasing order. So highest in the OF2, then O3 0, then -0.5, and then -1 in BaO2. So this is the correct order, and thus the option A is the correct answer. Okay, let's move to our next question. Question number 12. In the reaction 3Br2 plus 6CO32 negative plus 3H2O, giving us 5Br minus plus BrO3 minus plus 6HCO3 minus. So in this reaction, according to this reaction, which option would you choose? Options are: bromine is oxidized and the carbonate radical is reduced. Bromine is reduced and carbonate radical is oxidized. Bromine is neither reduced nor oxidized, or bromine is both reduced and oxidized. So you have 10 seconds to solve this question. After that, we will see the answer. Okay, let's see. The correct answer is option D, that is bromine is both reduced and oxidized. So if we find out the oxidation states in this reaction, so Br2 is an elementary state, so it will be having 0 oxidation number, then 6CO32 negative, then plus 3H2, it will give us 5Br negative, plus BrO3 negative, plus 6HCO3 negative. And we can see that in the product side, we have two Br molecules or ions. In first, we have Br in -1 oxidation number, and another is Br having +5 oxidation number. So in the reactant side, we have only one molecule of Br, that is Br2. So Br2 is reduced to Br negative as the oxidation number is decreasing, right, from 0 to -1, and Br2 is oxidized to BrO3 negative as oxidation number increases from 0 to +5, right? So oxidation number increasing means oxidation is happening, and oxidation number decreasing means reduction is happening. So Br2 reduced to Br negative, and Br2 also get oxidized to BrO3 negative, as we can see by the help of the change in the oxidation or difference in oxidation numbers, right? And thus we can say that the D option, which is bromine is both reduced and oxidized, is the correct answer for this question. Okay, let's move to the next question. Question number 13. The largest oxidation number exhibited by an element depends on its outer electronic configuration. With which of the following outer electronic configurations the element will exhibit largest oxidation number? We have given some electronic configurations in the option, and we have to tell that in which of the according to which of the electronic configuration which element should exhibit the largest oxidation number. And these electronic configuration are related to some element, so we have to tell the element which is having the largest oxidation number as per these given electronic configurations. So options are 3d1 4s2, 3d3 4s2, 3d5 4s1, or 3d5 4s2. So you have 10 seconds to solve this question. After that, we will see the answer. Okay, let's see. The correct answer is option D, 3d5 4s2. So according to this configuration 3d5 4s2, the element will exhibit +7 oxidation number, which is highest among the given options, because you can see here that 3d1 4s2 2 plus 1 will be 3, so +3 oxidation number. 3d3 4s2 3 plus 2 5 oxidation number. 3d5 4s1 5 plus 1 6 oxidation number. But in the D, 3d5 4s2 5 plus 2 7 oxidation number, which is largest, and thus the D option is the correct answer. Okay, now let's move to the next question. Question number 14. In which of the following compounds an element exhibits two different oxidation states. Okay, we have given options. We have to tell which one compound is present in the option which is having two different oxidation states. Options are NH2OH, NH4NO3, N2H4, or N3H. You have 10 seconds to solve this question. After that, we will see the answer. Let's see. The correct answer is option B, that is NH4NO3. So NH4NO3 is an ionic compound, exists in the form of NH4 positive and NO3 negative. So NH4NO3 will dissociate into NH4 positive and NO3 negative. And in NH4 positive, if we want to find out the nitrogen oxidation state, so let's suppose it is having X plus 4 for hydrogen is equals to plus 1, because the overall charge on this ion is plus 1. And so when we solve it for the X is equals to minus 3. Similarly, in NO3 minus, X minus 6, because O is having minus 2. Minus 2 times 3 will be minus 6, is equals to minus 1, because overall charge on this ion is minus 1. Now solving for X will be equal to plus 5. So two different oxidation state, right, in the same compound. This is the question, right? That an element exhibits two different oxidation states from the following compound. So nitrogen is the element having two different oxidation state in the same compound, and thus the option B is the correct answer. Okay, let's move to the next question, question number 15. When SO2 is passed through an acidified solution of potassium dichromate, the oxidation state of S, that is sulfur, changes from. We have given a reaction, basically reaction explanation, that when SO2 is passed through an acidified solution of potassium dichromate, the oxidation state of sulfur changes from which to which. So options are +4 to 0, +4 to +2, +4 to +6, or +6 to +4. You have 10 seconds to solve this question. After that, we will see the answer. Let's see. The correct answer is option C, that is S, oxidation state changes from +4 to +6. So let's write the reaction. K2Cr2O7 potassium dichromate plus 4H2SO4 plus 3SO2, where S is in plus for oxidation state, will be giving us K2SO4 plus Cr2SO4 whole thrice plus 3 molecules of SO3 plus 4H2O. And in SO3, the sulfur is in +6 oxidation state. So you can clearly see that the oxidation number of sulfur changes from +4 to +6, from SO2 to SO3. Right? In SO2 it is in +4, and in SO3 it is in +6. So changes from +4 to +6. Right? And thus the C option is the correct answer. Okay? Thank you.